Hi, everyone, and welcome to another episode of the Tracerco podcast. I'm Rob Hardy in the UK, and I'm joined as usual by my co host Bill Rivers in the US. Hey, Bill, how's it going?
It is going great, man. Sun's out, birds are shining. There is no rain. That is the most positive thing I can say right now that's going on in our area. No rain for once.
Good stuff. All right, so let's get straight into it today because we've got another guest today, haven't we?
What? Another guest? That's two, right? That's two
Yeah,
so far. We're gaining popularity. I like it.
yeah. So we've got one of the big hitters from Tracerco today. We've got Mr. Jim Bramlett, who's in charge of the Subsea division. Hey, Jim, how's it going?
I'm doing well. How about you, gentlemen?
Yeah, great, thanks.
Doing great.
So, Jim, do you want to give
Excellent.
us a quick introduction to your background and the kind of things you do with Tracerco?
Sure. Been kind of a long journey and a pleasant journey. So always been fun to be here. So I started out. Let's see, I'm on 25 years now. 25 years with the company. So
Wow.
in a roundabout way, so to speak, right? So I started out with a little infrared inspection company that was as an infrared inspector of fired furnaces, and I believe we were purchased by a company called TruTech many moon ago. And in 2006, Tracerco purchased TruTech. So I've come through Tracerco in a roundabout way, but overall service has been roughly 25 years. And then in the last 10 years, I've been heavily involved in the subsea world, subsea service side for Tracerco.
Yeah, great. And so what we want to talk about today is really the discovery tool. And on a previous podcast, Bill and I have spoken a bit about tower scanning, and we touched on that we can do more complex tomography type techniques where we take many scan lines in different orientations of the source and detector to get highly detailed cross-sectional images. So that's the kind of same technique we're talking about today, but it's subsea, isn't it? So maybe you could speak a little bit about the challenges and what drove the move to take this technology subsea.
Yeah, you bet. So, like you were saying, we started out with a concept from the downstream side, and we were heavily involved on flow assurance work on the subsea side. So, trying to identify blockages or buildups within subsea pipelines, right? One of the downsides to the original technology that we have is that it could get good information, but it couldn't tell them exactly what was in the pipeline, right? And we had been kicking around the idea for some time of developing a subsea CT scanner, which in turn turned out to be what we call our discovery tool. And what was quite interesting is roughly about that same time that we started really kicking in this idea, we had a customer in the Gulf of Mexico that had a major issue from the flow assurance side. And then talks developed between the companies of trying to progress this technology faster. And then due to our just phenomenal in-house expertise that we have over in our PD&I section, they embraced the challenge. We immediately went to work, and we came out with what I consider is just a phenomenal tool that can be used in the subsea world for flow assurance. As part of that, when we started doing our very first FATs with the client for this particular flow assurance project, I had somewhat of an inspection background, again, back from many moon ago, and it was kind of funny. It was kind of like, have you ever sat in a room and watched a dog see something interesting and his ears perk up and his head kind of turns to the side? Well, that was me kind of sitting in the back of the room in the FAT because I saw the inspection side of it immediately. That's what jumped out to me. And then that sent us down a whole nother wormhole of asset integrity with the tool. And to date, the tool is used more for integrity inspections than it is for flow assurance. It's still, don't get me wrong, it's a highly valuable tool for the flow assurance, but there's so many pipelines, especially in the subsea world, that are concrete coated or multi-pipe, so pipe and pipe, pipe and pipe and pipe, heavy wet insulated pipe that can't be inspected by traditional inspection methods. And that's kind of where discovery plays, or you can't get an ILI. So a lot of unpiggable pipelines, and it's really been embraced by the industry tremendously.
Yeah, that's great. And I think you mentioned a few areas there where Discovery excels, but maybe there's a few more we could mention. So I think you mentioned coated lines, complex arrays, bundles, piggybacks, but also deep water is an area where it kind of excels, isn't it? Those inspections in deep water conditions.
Yeah, massive deep water. As a matter of fact, we just finished last month a campaign at roughly 9,900 foot of water. So extremely, super deep water. And the tool performed flawlessly. Some of the other applications that we do quite readily are riser inspections, where we go in for fitness for service or life extension projects. We do a lot of riser inspections, TTR inspections. We have a massive campaign coming up where we're going to do 21 risers and TTRs for life extension. We've also just completed last year, and we're heading back out, next month, I believe it is, to do the first repeat scan. Last year, we did our first baseline of a brand new pipeline that was put in, where we will monitor the same areas over time and get the corrosion growth rates within the highly susceptible system.
So you kind of mentioned a little bit what the tool is about, some of the things it can do. Kind of describe for our audience like what the tool looks like. How does it work? How does it function?
So if you can imagine like a C clamp, right? So it's hydraulically operated C clamp. So it looks like a cylinder. It's approximately 6 foot in diameter, 7 foot in diameter, and probably 7-8 foot long. So if you think about relative terms, it's not much smaller than a work class ROV. And that's primarily due to buoyancy, right? So it's an extremely heavy tool. So we've got a lot of buoyancy on the tool itself, but it will hydraulically open, clamp on the pipe. The ROV will deliver us to the pipe. Once we clamp on the pipe, then we have full control of the tool, and we can actually walk the tool. So whatever the distance or length of scan that the customer wants, we can actually walk that tool within funnel orientation.
So basically, you just get a piggyback ride from an ROV, drops you on the pipe, you say, "See you later," and then you just kind of go out and do your business and take the pictures as you go along that pipe.
Close, but not exactly, right? So we do have an umbilical that is connected to the ROV, and that's how we get our comms, our electric, and our hydraulic function of the tool, right?
Gotcha.
He doesn't have to necessarily keep a hold of us. As a matter of fact, if we're going to walk it, he's going to let go and just hover in the area of the length of the umbilical, right? But by doing so, by having that umbilical, we get real-time data topside. So that's extremely valuable for the customer and the project itself, because it gives us the flexibility. In other words, we don't have to finish a project or come home to the beach and realize we either didn't get the data that we wanted, or we stopped the data in the middle of a defect or something similar. We have the flexibility because we get that information right then and there. It's analyzed. We can look at it. The client rep looks at it. Decisions are made right then and there to either expand the scope of work or even potentially reduce the scope of work, depending on what we're seeing right then and there.
So it's just like tower scanning, Rob, like real-time data while the pipeline's active, right? That's what we do. That's one thing that we excels at Tracerco. We'll give you real-time data right then, right there.
Yeah,
And
and
again,
you mentioned
massive from a value standpoint, right?
Yeah.
And you mentioned sort of taking pictures there. One of the things I love about Discovery is you get these beautiful tomograms, and it shows what's actually going on inside the pipe, and it's this sort of huge amount of data, but it's condensed down into these nice pictures that you can interpret really easily. And we mentioned that there's applications in integrity and flow assurance. One of my favorite examples of Discovery, Jim, is probably the one where it's the piggyback line, and we were looking at the integrity, but we actually found some data on the flow assurance in the other line as well, didn't we?
Yeah, we did. So it had a line that had a piggyback attached to it, right? So very, very difficult to inspect. They can't remove the piggyback line. So we actually had to build an ROV adaptable adapter that would go over both of those lines. Then we would clamp around the adapter and ended up scanning both of those lines all in one scan, right? The target line was a production line, excuse me, and they had a gas line. Uh, 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 I believe it was a gas injection line that was piggybacked on this, and we found severe condensate that was unexpected that was sitting in the gas line. So we still got all the integrity data on the process line that we were looking at, but we also raised a lot of red flags to the operator for early identification of this condensate layer that was sitting in the line, which obviously is a corrosion issue.
Yeah, I think it's a really good example. And something else we've seen a lot recently is as assets are aging, we're sort of monitoring severe corrosion and actually helping to guide repair strategy and where repair clamps can be positioned and that sort of thing. That's kind of become more popular in the last few years, I think, hasn't it?
Absolutely. So one of the interesting takes that's happening now is obviously if you have to run an ILI tool, there's advantages to running ILI and there's disadvantages to running ILI, right? You know, I'll never, as an old inspection guy, I'll never downside ILI runs because you get the data on the whole flow line, right? But you've got increased risk of getting the pig stuck. You've got the operators responsible for any damage to the pig itself. You've got potentials for bad runs, and you've got loss of production, right? That's key. So a lot of times what we're seeing now is companies will run that ILI run to identify, like Rob said, they'll identify suspect areas or areas of integrity issues. Then over time, if it's bad enough and they need to do a repair, they'll send us down to verify exactly where that location is and get a second reading on it. Or if it's not to the point where they're ready to clamp it, we can go down periodically, like typically every year, and we'll go remonitor those known locations while they're still in full production and start looking at corrosion growth rate. So again, another massive value tool to reduce risk to the operator itself and loss of production.
So what is that worth to a customer? I mean,
That-
you've described some very, things that can go incredibly wrong with the pipeline, but like in tower scanning, when Rob and I were talking about this in a couple podcasts, you can put a dollar figure. Sometimes you get bad product, you get, downtime, and that costs, hundreds of thousands of dollars sometimes per day. What's that worth to a customer? I mean,
Well, I mean, it's pretty easy to extract from a production standpoint, right? So depending on if it's a gas line, how many scuffs they're being able or pressure they're being able to put through the line, or if it's an oil line, how many barrels per day, right? So let's say you've got a pretty decent chunk at 4,000 or 5,000 barrels of oil per day, right? And you're down several days or several weeks because typically if you're going to run an ILI, you're going to go in and you're going to run some cleaning pigs, you're going to run some gauging pigs, you're going to run some caliper pigs. You're going to progressively pig up to when you put the super expensive tool in. So you're talking about a tool that's worth seven figures more than likely, plus loss of production, plus these other pigs, plus all the ancillary cost of crews, of pigging crews, of launchers, receivers, all this other infrastructure and equipment that must go into that. So you could jump into millions and millions of dollars very, very quickly. And you can even double or triple that if you're talking about a subsea launch and subsea receive. So if you're not receiving or launching from a platform, now you've got MSV vessels in field, you've got, more than likely two vessels in the field. It gets really expensive. And some of these vessels are hundreds of thousands of dollars a day.
so it adds up pretty quick. So
It adds up extremely quick, right? So if you can, the less amount of time you can spend pigging and the more time you can spend while you're still making, or you can inspect while you're still making money, the less of a cost burden, much less of a cost burden it is to the operator. And then how you put a number on risk, I can't do that. I mean, I'm sure the operators have a risk factor in everything that they do, right? But
That's a great point. Risk.
there's got to be there's got to be a rather large risk number involved in different operations.
All right, great. So there was just really one final example I wanted to mention, which again is one of my favorites. Was I think there was an example where it was a riser and there was a pipe within a pipe system, and the asset had changed hands a few times, I think, and they found like an umbilical or something that they didn't even know was there beforehand.
Yeah, so that was an interesting project, and as a matter of fact, Rob, that's one of them that we're fixing to go back out and do. That's part of the 21 risers and TTRs that we're fixing to do. So this particular asset had changed hands, I think, 3 times, right? So the original drawings were non-existent. They couldn't find them. So we were going out for a pipe and pipe riser application, and then one of them was a pipe and pipe and pipe. So it was actually had a gas lift line within the production line. So the first thing that we found is that it was real interesting. We did the pipe and pipe and pipe. So the pipe that had the gas lift riser, they weren't concerned with the gas lift riser. Obviously, they were concerned with the production pipe and the outer casing. And one of the things that we actually noticed was, so you can imagine we're scanning over a certain time set, right? So everything that's stagnant or still in that scan stays perfectly clear, right? Anything moving will have a shadow or blur to it. And one of the things that we found is that unbeknownst to them, they had severe movement within the gas lift riser. It was bouncing all over inside the production pipe, right? So even though that wasn't part of our scope, we were able to identify that. And then, of course, the operator now has to look into, vibration issues that could have been going on with that gas lift riser bouncing back and forth. Then we went to inspect the one that Rob was talking about. We started inspecting this line, and all of a sudden we kept seeing in the annulus between the outer pipe and the production pipe, we started seeing these tubes, these round circles that were encompassing the production pipe. And the operator was like, "What on earth is that?" And we were like, "Well, we were kind of hoping you could tell us, because none of this is on the drawing." So, but come to find out, we ended up finding a collar and several collars up this pipeline. And what it was an old fluid umbilical that had been designed inside the annulus of this pipe, and nobody knew about it. So, obviously it had been terminated at some point in time, and it was just sitting in the annulus of this pipe, and we picked it up clear as a bell. So it was kind of interesting. Not only was it interesting, but it obviously, for the operator, it kind of just totally sold them on our technology for us to be able to see those umbilical sections sitting in there. So yeah, it was unique. We found some interesting stuff.
That's just crazy.
Yeah. So and the tool is so phenomenal. It can even I'll tell y'all one more. On the original job that we did, it was real interesting because we had found I'll give you an example. We had an operator that had a full bore blockage. Luckily, they had sister lines, right? So they were able to take the production out of the line that was blocked, dump it into the sister line, and maintain operation, but not at the levels that they wanted. So they really needed to figure out what we were going to do with the line that was blocked, and what was it blocked with, because they thought they had a hydrate. They had just come off of a turnaround. They knew they had a little bit of elevated DP before they started the turnaround. When they started bringing production back in the line, they blocked off, right? So they immediately thought, okay, we hydrated up. We had some water in the line. We hydrated on restart. So they just started doing some pressure cycling, right? Draw down pressure, hold, raise pressure, try to get it to move. Every time they raised pressure, they got a little movement, and they thought, okay, we're moving this hydrate. So they continued to do that until they maxed pressure on the pipeline. They couldn't get any movement anymore. And at that point, they went, uh-oh. And hence came Tracerco. We developed the tool. We went out there. And what we found a massive asphaltene blockage. And it was really interesting because we saw the changes in the asphaltene as we went down the line. So we not only that, but right before they called us out, because they had asphaltene, they dumped a big big head of xylene on it to try to do a xylene soak on it, right? So we went in, we found the xylene head, we transitioned from the xylene head to a massive full bore blockage asphaltene. Then as we left that full bore blockage asphaltene, we started getting into what we call this honeycomb look. So it was a real dry asphaltene with a bunch of trapped gas into it. And as we went further down the line, it transitioned from this real dry asphaltene to more of a liquid tarry asphaltene that had sloughed down the pipe some. But we still needed to figure out where we had communication to, right? So we had these air bubbles or air pockets that we identified in the asphaltene that was more the honeycomb shape, right? So we were able to go in and have the operator pressure up. So we did the original scan with no pressurized gas in the system, and we found low pressure gas. When they pressured up with sales gas, we went back and inspected those same locations, and we could see the high pressure gas. We could see the density change in the gas, which afforded us the ability to identify exactly to what point they had communication to. So even though that was almost a full bore blockage, we could still tell that they had communication up to a certain point. And then further down the line, we identified where there was no gas change in there. So we knew that we had a full bore blockage between point A and point B. Then the thought was, oh my God, we've dumped all this stuff into our sister line now. So what have we done to the sister line? So we went and inspected the sister line. And what was interesting is we didn't find an asphaltene in the sister line, but we identified a massive scale issue that had probably an inch and a half of scale on the pipeline. So it allowed them to save that pipeline by using scale inhibitors and trying to remediate online the sister line that was still flowing and save it. Because what they would have done is they would have started just dumping asphaltene inhibitors into it with the thought that, well, we're just going to asphaltene it up, and it wouldn't have done any good at all on the scale issue that they had. So it was a really, really unique project.
Yeah, great. All right. Yeah, well, that's all I got. I think that's some great examples, Jim, on the discovery tool and the flow assurance and the integrity aspects and a few other things in between. Anything else from you, Bill?
No, it was good. It was very interesting. Again, Jim, thank you so much for coming on. Rob and I appreciated a bunch for you being here today. For all you folks out there that want to get in contact with us, you can catch Rob, myself, and Jim on LinkedIn. On behalf of Rob and myself, we appreciate you listening and having a great day.